carbon silicon analyzer equipment to foundry. Sir joined PMI in 2012. Till today, Sir is working with various capacities. Sir has started his journey with sales, services, team leader, then become a zonal manager. Sir is managing North Karnataka, Maharashtra, Goa zones. With this brief introduction, I present Mr. Chidambar Kulkarni sir. Thank you.
Thank you, Soumya.
Thank you. Thank you. Am I audible? Am I audible? Last row. Okay, fine. Yeah.
Now I request Dr. S.G. Gollagi sir to welcome Mr. Chidambar Kulkarni sir.
Yes, okay. Yes. Thank you, sir. Thank you.
Thank you, sir.
Thank you. Thank you, sir. Good afternoon. Uh, the great day. Yesterday it was. Hope you enjoyed. Okay. So you realize what is IoT practically. Now today's session is something beyond that. Okay. So today's session is what we are sending the data to cloud and retrieving data from the cloud and making some analysis. Okay. So today I brought, that is we having a IoT kit. We call it as our IoT kit. It look like something like this. This is IoT kit. Okay. Please switch off this. Please switch off. Okay. This is the IoT kit. Okay. Here we are having a Raspberry Pi. This is a Raspberry Pi. And this is Arduino. Either you can use Raspberry Pi and Arduino. So we call as 2-in-1. We call as a 2-in-1. Okay. But we prefer Raspberry Pi. Why? I'll tell you afterwards. Okay. So this is a board. This board consists of 5 sensors. One is temperature, light, ultrasonic, gas, and soil moisture. Okay. We have a 5 sensors. Then we have some actuators like relay, buzzer, motor purpose, and some keypads with LEDs. Then we have two display units, LCD and 7 segment, and there is one Wi-Fi module and Bluetooth for Arduino and not for Raspberry Pi, because Raspberry Pi is having inbuilt Wi-Fi module and Bluetooth. Arduino doesn't have inbuilt Wi-Fi module and Bluetooth. Okay, there is a major difference. So always use for Raspberry Pi. This is a major difference. Okay, clear? Now, what we are doing here? What I am doing here is, I am reading the census data, all census data, and I am sending into the cloud. Okay, so how I am sending into the cloud? How is my program? Okay, I'll go through that. So this is my program. This is my program. Again, we have called some libraries. Okay, yesterday we used machine, import time, some things. Okay, this is also on a Python code, same on Thony Python. On Thony Python. And before that, how many of you work on Raspberry Pi? Please raise hand. Anybody has worked with Raspberry Pi? Raspberry Pi, one. Anybody else? You. Okay. So Raspberry Pi is again a main controller is ARM A series. Have you know this? ARM A series. Raspberry Pi's main controller is ARM A series with other accessories. Okay. So here it has its own OS, that is called Raspbian. That is called Raspbian OS. Okay. That we have installed in this Raspberry Pi. Okay. Like how yesterday we did that firmware installation. Like that we have installed here Debian, Raspberry Pi, Raspbian, Debian OS. It is a flavor of Linux. It is a flavor of Linux. Okay. So in this we are having a Thony editor. Thony editor. In the Thony editor we have written the program. Okay. So there are some small programs are there. I don't want to show that all small programs, buzzer on and off, LED on and off, all the things. I want to show a main program. So here I'm using so many libraries. The first one is RPI.GPIO as a GPIO. Yes, who has worked on Raspberry Pi? Please let me know what is this module is. RPI.GPIO as a GPIO. Are you use this or 0 pi you use? RPI.GPIO is Raspberry Pi's general purpose input output. I am declaring as a general purpose input output as alias name. Second one is import time. It's nothing but for the delay purpose. Okay, for a delay purpose. The next is math. Math is for some mathematical application purpose. Request and JSON. JSON is nothing but those who are from CS background, they know very well JavaScript object notation. Am I right? JSON. And request is to request the UR library to open the URlib. Okay. So that is I am using the URlib2, import URlib2. Then Adafruit underscore DHT. This maybe know everyone. Adafruit underscore DHT, this module. This is used in Arduino with DHT sensor. Anybody's work on this? So this is one module that is whatever that sensors are there. Some sensors are having that inbuilt characters are there, no? They made as a software and they made as a library for that. So that is one is that Adafruit underscore DHT library. Then Adafruit underscore GPIO dot SPI as SPI. What I'm doing here is I'm having some analog sensors and some digital sensors. Gas and soil moisture sensors are digital analog sensors. DHT11 and light and ultrasonic. First three sensors are digital sensors. Okay. Once again, I'll tell you. Don't get confused. These first three are digital sensors. Next two are gas and soil moistures are analog sensors. Okay. Now what I'm doing, the whatever the digital, whatever the Raspberry Pi GPIOs are there, Raspberry Pi GPIOs, those all are digital GPIOs. You cannot directly give analog output to the Raspberry Pi inputs. This is very important. When you're using a sensor, what sensor you are supposed to use, and you are connecting to the particular controller GPIO pins. So what that pin is. So Raspberry Pi pins are all digital GPIOs. Digital GPIOs. So whatever the two sensors are there, gas sensor and soil moisture sensor, those are analog sensors. So I cannot directly give that sensor output, the sensor output to the Raspberry Pi GPIOs. So what I am doing, I am using ADC converters. Okay, ADC converter. To make a conversion, I am using MCP3008. There is some IC called MCP3008. It is having a 8-bit converter. Okay, so two sensor data I am connecting to the that MCP3008 IC. So this whatever the import Adafruit MCP3008 is there, no? So that library will take care of conversion A to D. Okay, that module take care of conversion of A to D, and then whatever the SPI is there. So I have to connect one controller to the another controller. I have to use some protocol. Okay, so I cannot connect simple wires. If I have to transmit data from one PC to another PC, we have a set of protocols, no? So like that in controllers, I have to use either UART, I2C, SPI, USB. Okay, you know these parameters. Hope you see backgrounds. You know this. So what I am doing, I am sending that MCP3008 data, that IC data to the Raspberry Pi using the SPI protocol. Using the SPI protocol. Hope any confused? I am having my I'll clear it here. I am having my Raspberry Pi and I am having my that MCP3008 IC. Okay, so if I want to send this data to the Raspberry Pi, this one, I cannot directly send. I have to use some protocol here. So in that I am using here is SPI protocol. SPI protocol. Okay. So through SPI protocol, I am sending the digital data into the digital pin of the Raspberry Pi for that purpose. Next, now so where I am sending, for the time being you forget this, where I am sending, I am sending to cloud. Which cloud? Thingspeak.com. Why I am choosing thingspeak.com? Because it is a free cloud. Up to 15 GB data you can store. Up to 15 GB data you can store. You can create n number of accounts with the different email IDs, and it has some restrictions. So how it looks? How it looks? It looks something like this. When you create account, you will get a channel ID, author. This is my channel ID. Okay, this is the author. My name is there, and this is page is something like this. Cloud. Okay, it has a private view, public view, channel settings, saving, sharing, API, data import and export, etc., etc. Okay. Now here, when you create a channel, okay, how many of you are having account in ThinkSpeak? Account in ThinkSpeak? Sir, you have? Anybody else? The one thing is we don't have here net. I think mostly mobile net is there. You can create here also. I can show if you want. Mobile net is there. If mobile net is there, go to thingspeak.com. I can show that also. Go to thingspeak.com. You'll get a page like this. It is a MathWorks. It is a MATLAB cloud. If you have an account in MATLAB, you can use the same password, username and password. Okay, it is a MATLAB cloud. So this is thingspeak.com. Okay, now go here for login. What is this happening? It's getting refreshing every time. Okay, okay, you go somewhere here. You'll get a sign in option. Okay, give your email ID there. Sign in option. It asks the credential. Give your email ID. So what we'll do? You create account. Then through your account, we will send the data to the cloud. Okay. Just create account. It's very simple. Okay. Once the account is created, you'll get a new channel. So put email address, location, first name, everything like this. Some students, no students are there. At least we get students. Students, your student. Put your email ID. Put your email ID there. Okay, we'll create his account along with you. Type your email ID. Okay. Go to this India. Because I'm having 4-5 accounts are there. So it is very difficult for me to create one more. Okay, your first name? Sharanu. Okay, last name? Okay, take it down. Say continue. Use this email for my math work also. Click it. Wait, 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 wait. Processor. Okay. Click and continue. Okay. So what is ask? Go to inbox. Go to your email inbox. Okay. You'll get some link is get. You'll get a link. Click on that link. Okay. Click on that link and click continue. Slide. Click continue. Okay. Go here only, no? So you can go from here because they want to also see. What is Gmail, na? Open here Gmail. Wait for it. Okay, no problem. Gmail open ಮಾಡಿ ಪಾಸ್ವರ್ಡ್ ಗೊತ್ತಿಲ್ಲ ಗೆಟ್ ಲಾಗಿನ್ ಕುಡು ಕುಡು ಕೂತ್ ಮಾಡು ಓಪನ್ ಕೂತ್ ಮಾಡಲಿ ಹಾಂ ಫಸ್ಟ್ ನೇಮ್ ಕ್ರಿಯೇಟ್ ಬೇಡ ಲಾಗಿನ್ ಆಗಿ so I'll tell you how to create account, how to create a channels, what are the API keys and what are the importance of those API keys with respect to the sending data to the cloud. Okay, so this I'm telling. Wait, enter password. Anybody else, why this coming? Anybody knows this? Security, what security is? One layer, two layer, three layer securities. Two layer security options. This is given by the Gmail people. So nobody has to be hack your this one. This one. Yeah. Okay. So he's in his Gmail account. He's clicked on that link. Okay. So he got verified. He got verified. So there it will ask create a password. There it will ask create a password. So you can give a password. So that password you will be using for your ThinkSpeak Cloud. Okay. Exclusive for ThinkSpeak Cloud. Oh, 85 storage used. So slow. So it is slow. Sign out ಹಾಕಿದ್ರು Verify email. Click it. Sometimes issues are there. Net issues, latency. Okay. At time. Okay, no problem. You go to sign in. Things speak. Just continue, Mr. Jay. Continue. Okay. Continue. Put your email ID. Password is create password. Give some name. Password. Okay. Password should be between so many parameters. Okay. You know password. Okay. Continue. I accept service agreement. Continue. Continue. Okay. Okay. You sign up successfully. You say okay. Welcome to ThinkSpeak. Okay. Now what's happened when you create accounts? Okay, it asks for what purpose? You use for just last term students teaching research academy. Okay, then write your college name KLE. Then student, type a student. Okay, what is the name of your course project? You like IoT, right? IoT. Okay, you write something here. If you want, I'll leave it. No problem. Okay, say okay. So these credentials, they make some analysis. Who all are using our clouds? Okay. Now this is you have a created account with here. Okay. Now the first time you will get like this page when you create a first time accounts. So you have to create the channels. So what are the channels? In that channels, I'm sending my sensor data. Okay. In that channel, I'm sending my sensor data. Click on new channel. Click on new channel. So here these are the fields. The first one is name, whatever name you use, it will display there. And second is description, leave out. These are the fields. Scroll down. Okay. Take up. Up. Okay. Field 1 to field 8. That indicates that up to 8 sensors you can connect. This is a free cloud, so maximum you can connect 8 sensors. If you pay for more, you'll get a more fields over here. More sensors you can connect. So what we did here fields, field 1, field 2, field 3, field 4, like this, field 8. Okay, take it down. So this is metadata we not require right now. Take it down. Okay, tags required, and you can share your that page to any of your friends. Okay, even you can link this to the GitHub. Okay, and location we don't want. Take it down. You can make a video of this. Okay, then you can share the URL also. Oh, what we'll do? Take it up. Field 1. Field 1, click on that. Field 1, you write TEMP, temperature, or full light, whatever you want. So first field is temperature. Second is humidity. Second, you click on humidity. Okay. Third, you click on light. Fourth, you click on ultrasonic distance. Fifth, you click on gas. Ultrasonic or gas, ultrasonic like. Okay. Next, gas. So I am having 5 sensors. So I am choosing 6 fields. DHT11 is having a 2 sensor. It is the temperature as well as the humidity. Okay. Third is light, ultrasonic, gas, and soil moisture. Okay. I am having 5 sensors, 6 field I am octane. Okay. So if you are using a free cloud and if you go for more sensors, you have to create one more account. In one account, 8 fields. In another account, another next 8 fields. So you can combine that also. Okay. Fine. Okay, leave it. Okay. Say finish. Take it down, full down. Down. I say save it. Save channel. So when you save the channels, you'll get like this channels. Okay. Take it down. So this is field 1 temperature, field 2 humidity, take it down, light, ultrasonic, gas, okay, this much, these fields. So in these fields your sensor data goes. So how it goes? How it goes? Now I'll tell that. Thank you. So I'll open my this one, sign out and sign in. So many I'm created, so that I'm this one. Okay. Now this field you got. How to create a fields? You got it. Okay. Now how to send the data into the fields? The first is it gives you the API keys. When you click on API keys, it will give the API keys. It has a two API key. One is write API key. One is read API key. Okay. This is something called the gateways to enter into the cloud. Okay. You're supposed to know this. Okay. So what I'm doing here is, if I want to send the data to cloud, I'm using write API key in my Python coding. In my Python coding. So where it is? So this is my API key VUO BPZ. When I go to Tony, you can see VUO BPZ. Okay, this is my API key. So where I'm sending? I'm sending to the thingspeak.com through my API key. So my API is this through my API key. Okay. Now what's happened next? That Raspberry Pi is having two SPI ports, port 0 and port 1. We'll use the SPI port 0 here. Then MCP is there, no? MCP is again, but nothing but it is converting my analog signal into the digital format. Okay, for that I'm using here this particular instantiations. Then Raspberry Pi will work on two modes, BCM mode and bold mode. BCM mode and bold mode. So how it looks? So whatever that internal numbers are there, these are called BCM modes. BCM mode pin numbers. So this is Raspberry Pi. Okay, this is Raspberry Pi. These numbers are there, no? These numbers. These numbers are these BCM numbers. 1, 2, 3, 4, like this, up to 40. This is a 40 pin. And those with the green color, you can see that these are called BCM mode. BCM mode is nothing but SOCs. SOC is system on chip. So whatever that IC's pin numbers are there, no, is that pin numbers. So you can access in two ways, either in a bold mode or in BCM mode. So when you accessing bold mode, you have to use this pin number. Okay, this is called 40 pin header pins. 40 pin header. Okay, and these are called BCM mode. Whatever green color is showing, this is BCM modes. That is that IC's particular pins. This is called a SOC, system on chip. Okay. So what we have defined here in a program, it is BCM mode. Okay, pin is used in BCM mode. Then, sorry. Then I'm connected using these pins. Some are make as input, some as make as outputs. Temperature sensor I'm connected to the pin number 4. light is connected to the pin number 13. Okay, ultrasonic. How ultrasonic works? How ultrasonic works? You know, basic physics. Basic physics. IoT is full of electronics, physics, computer science, mechanical, everything. Okay, so I'm converting sound into distance. What I'm doing? Ultrasonic. Time into distance. So I'm triggered some signal. It will hit to the object. It will come back. Okay. So that is this one. Okay. So that's using the one is trigger pin and one is echo pin. Trigger pin is what? To hit the object, and echo is what? To receive that signal. Okay. This one is there. And initially I'm making some initializations, that is, sorry, temperature, humidity, light, initial value should be 0. Okay. I don't want to take any random initial value. I suppose be 0. Then print some message. While true, wait for 2 seconds. First it will sense the humidity and temperature values. Okay, temperature and humidity. It will display that humidity and temperature. Next, light value. Light presents or absent, detected or not detected. Next, triggering the that ultrasonic. Okay, ultrasonic. So this is what something set trigger pin. So it triggers, wait for seconds, it will come back, reflect back, then measure that and convert it into the distance. Okay. But condition here is these sensors are educational sensors. These are not industrial level sensors. These are whatever I'm using on a board, it's an education sensor. This precision is very low quality precisions. What means? Okay. Not so. Industrial sensor high. So what we are given here is the distance should be measured between 2 centimeter to 400 centimeters. I'm given the condition because it's ultrasonic, whatever ultrasonic we are used, it will measure between 2 centimeter, between 2 centimeter to 400 centimeter, in that range. Not below 2 centimeter, not above 400 centimeters. Okay. So this is the condition I'm given over here. If it is beyond that range, then it gives the out of range message. Okay. Then here gas value, gas and moisture sensor. So I'm using 8-bit 8 channel ADC is there. Channel 0 I am connected for the gas purpose, and channel 1 is connected to the soil moisture purpose. So as I said, it is a analog sensor. So I am converting this into the digital format using MCP. Okay, using MCP function. Once I am read all this, then I have to send those data to the my base URL. What is my base URL is thingspeak.com, and where the field 1, 2, 3, 4, field 1, 2, 3, 4 with the variable names, temp, humidity, light value, whatever we are given the field names, those names. Get the message, data sent to cloud, wait for 2 seconds, and this will be in while true. This will be in a flight loop. So all the sensor data will be reads, it sends to the cloud. It reads and sent to the cloud. Okay. When I run this program, this data will goes to the cloud. So to run this program, I have to use a terminal window. Refresh ಆಗ್ತದೆ ಇದು ಅಲ್ಲ ರಿಫ್ರೆಶ್ ಆಗ್ತದೆ ಇದು ಕೇಬಲ್ ಪ್ರಾಬ್ಲಮ್ ಓಕೆ ಹೌದಾ okay fine. Now to send the data to the cloud, I have to go to first the terminal window, then I have to go to my path cd home, Pi, desktop, Raspberry Pi tested programs. Okay, because my program is in home, Pi, desktop, Raspberry Pi tested programs. In that, ThinkSpeak send.py is my program name. Okay, ThinkSpeak send.py is my program name. So I have to go to first that folder, then I have to enter the command sudo python ThinkSpeak send.py. This is a command to execute the Python coding programs. Okay, when I say enter, first it will wait for 2 seconds. Okay, then it will scan the sensor data one by one by one. Okay, it will read it, then it will send to the cloud. So once you send to the cloud, you will get a message, data sent to cloud. Okay, data sent to cloud. So this is an infinite loop. So if I want to see these data, I have to go here, I have to go to my private view here, this one, cloud. So here you will get entry less than minute ago, and I'll get my data over in the fields, respective fields. Okay, when I hold the mouse pointer, the last one, it gives a date, time, okay, and what is the value of that. If a field one is temperature, then temperature, humidity, okay, humidity, light, distance. Now it is light is 0 is there. Light detected or not detected? Sorry. Light detect is. Okay. Now I close this. Light not detected. Okay. So when I go to cloud, this will go up. Its take latency time is there up to 15 seconds. Okay. Up to 15 seconds. Refresh it. Light not detected. Yeah. You see that changes happened. Okay. The changes happened there. Okay, so this is a free cloud, so latency time is more. Your sensor will read this data first. Okay, but when sending to the cloud, it takes some 15 to 20 seconds times. Okay, so this is what is sending data to the cloud. Okay, so this is what is sending data to the cloud using ThinkSpeak with the API keys. Now what is the use of this? What is use of this? Monitoring. Yes, I send data to the cloud. Now what is use? Actuators. Yeah, one. Next, we can make analysis. We can make analysis. We can predict something from this data. We can predict something from this data. So how to make that one? So when a data is there in a cloud, okay, a data is going into the cloud, okay. So first let's stop this running program. Control C, stop this. So my data is there in the cloud. What I will do? I will import this data in the form of Excel format or CSV format. CSV format. Okay. So take it down. Export. Export from the ThinkSpeak with Indian Standard Time 5:30 Kolkata. Download. So here I'll get data in the CSV format. Once I got this data in the CSV format, what I can do? I can run machine learning algorithms. Okay, I can predict. I can do anything. I can use for machine learning algorithms. So this is the data. Field 1, field 2, field 3, all this. These are data. So these data, using these data, you can make analysis. You can make a predicts. Okay. So live example is, how many of you have visited Easy Bay showroom, cloth showroom, or even if you visited that trends and all these things. Okay. So what they're doing? They're using same concepts here. So they have a lot of showrooms are there in taluka wise. Am I? Trends is there much more this one, especially trends. So they send some jeans pants, blue color, black color jeans pants. Okay. When the moment it comes to the like Chikkodi trends near that circle, okay, they put a tag, they make a scan, they put it in a rack. Okay. So as a customer comes, he take it out, he make a bill. Once he make a bill, that data goes to the main office of the this one, their head office, maybe Bangalore, maybe somewhere it may be. Okay. So the person who is sitting there, he can see that what is it going on there. At Chikkodi, this one, Trends Mall, how many jeans pants are sold out by till today? By evening, by afternoon, or by 1 week, or by 1 month. Which color pant, which size, which size, so everything. So what they will do, if X pant, if red color, sorry, if black color pant is selling, blue is not selling, then they give a more discount to the blue color. They put a label. So that will sell automatically. So they make some analysis. Okay. You see this, you see this. You see how many of you traveled in Bangalore metro, even Chigri bus. Of course, Chigri bus, sometimes they use a ticket by hand. They're not allowed to scan. Okay. Actually, it's supposed to be scanned. So what will happen in Chigri bus or in Bangalore metro, they give a token or that QR code. We put it in, door will open, we'll go in, and then we travels at the exit. We again uh, stick that this one. So that will make at the end of the day how many people are traveled between one place to another place. From suppose Yeshwantpur railway station to Majestic, how many people are traveled? From Yeshwantpur railway station to the Lalbagh, how many people are traveled? From Majestic to Lalbagh, how many people are traveled? They make analysis within a fraction of seconds with this data. With this data. Okay. If you see in contrast with the KSRTC department, what they do? They tear the tickets. Okay. They write in that log sheets. They go to the that bus stop. One person sitting, the controller or something. Okay. So he goes there. He tell to that, sir, you is no ticketry, is ticketry, is ticketry, is ticketry. He will enter in his diary. 3-4 diaries are there. He'll enter in that diary. Then that diary goes inside the depot. Then they will enter in the Excel sheets. And then they will send to the KSRTC main office. How tedious this is? How tedious? This is the beauty of IoTs, real time. So collecting a data and then making some analysis on the data. That's the importance of the IoTs. Okay. Now this is one part. This is one part. I am reading a data, sending into cloud. What is the next part? I'm making analysis is one part. What is the next? I have to retrieve data from the cloud and I have to make something, especially in industries. Especially in industries. Okay. What we did yesterday? If temperature goes, then light on. But what we did there, we using only web page, simple applications. Here I am connecting to the cloud. Okay, here I am connecting to the cloud, and then to retrieving the data from the cloud. Okay, I supposed to retrieve data from the cloud. So, sir, continue ಮಾಡೋಣ 10 ನಿಮಿಷ ಬ್ರೇಕ್ ತಗೋಣ. So another 140 minutes. What we'll do? We'll take 5 minutes breaks. 4 o'clock. Yeah, yeah. ಅಲ್ಲ, because suddenly become headache ಭಾಳ ಆಗ್ಬಾರ್ದು. After food, the digestion is very difficult. Because food has to digest and the knowledge has to be digest. Two things has to be digest. Okay? Okay. Fine. Okay, fine. So once the data is in the cloud, I have to retrieve that data and I have to run some applications. Then only it is used for in the industries. Okay, making analysis is one part. Now for industry levels. So what I am doing, I have to retrieve a data. So I am having one program that is retrieving a data. ThinkSpeak read.py. Yeah. Okay. I'll shut down it. I'll connect that kit and show you that. Okay. Okay. Meanwhile, uh, how my sensors are connected to the Raspberry Pi. This is my full manual is there. Yeah, ultrasonic. Okay. This is called, we call as a schematics. We call as a schematic. Schematic is nothing but the sort of a circuitry. It's not a pure circuitry. It's just overview of the circuitry. Okay. So what we are doing, this is ultrasonic sensor. It has a 4 pins. It has a 4 pins. So one pin is VCC, trigger, echo, and another is ground. Another is ground. So what we are doing, here we are use the pin number for echo, trigger, and VCC. Those all will be mentioned in that particular manuals table. Soil moisture, SPA, DST11 light, ultrasonic. Okay, ultrasonic. Okay. So what is there? So this is my Raspberry Pi board. This is that 40 pins, and I am having a sensor here. It has 4 pins. Okay. So ground is connected to the ground of this, and then echo is connected to the pin number 2. That is pin number 2 means in GPIO. This is for trigger, and trigger is pin number 2. 2, 3. This is trigger. This is echo. Pin number 1 is ground, and pin number 4 is VCC. VCC. Okay. J7. Yeah, RM4. Okay, fine. So what we did, the RM4 is for ultrasonic here. This is RM4. Okay. This is RM4. This is ultrasonic. Pin number 1 is ground. That is pin 37. So this 37, somewhere 37 has goes to the ground. Then 35 is for trigger. Then ground, sorry, ground is ground. 3 is ground, na? 37 is for trigger, 35 is for echo, VCC and ground. Okay. So this is connected over here. Like this is connection. This table is something like this. Connecting to the ultrasonic sensors to the Raspberry Pi board. Okay. That is a simple concept. Like how you connect to the your other boards. I don't have the circuitry, full circuitry here. They have shown that's okay. So like this, you have we are getting we are giving that schematics, the way the pin has gone, and where to connect all these things. Okay. So this is one concept. Next, I have to retrieve a data from the cloud. I have to retrieve data from the cloud. So I have to use ThinkSpeak read. I have to use from other board. No? Shut down. This is just like a mini computer. As yesterday I said, this is just like a mini computer. It's board it better. Board it better. Almost. Huh. Outre? No. Cable problem. Huh? Off model motor. Off model motor. Anush. Off model motor. Power off one. On motor. Yeah. Yeah, we'll have tea and we'll come back. API key in my program. Okay, so I'm having this program here. I'm using this read API key, DA key, I finalize something. Okay, DA key I finalize with the channel ID 660. Yes, sir. With the 660 channel ID 660749. Okay, those things I'm using in my program. Okay, what I'm doing here is I'm making some LEDs on and buzzer on if condition temperature condition is greater than equal to 18. Okay, I'm retrieving this from field 1 with thingspeak.com cloud. Okay, with the field 1. Okay, field 2 is relative only field 1. So that temperature is greater than 18, then LED should be on, wait for 5 seconds and buzzer should be on. And I'm supposed to get temperature is too high. Else buzzer should be 0 and temperature should be normal. Okay, so this will be using response code through URL a variable con in that reading the data. Okay, so when I run this program, say enter, see temperature is above 18. So the temperature is high, buzzer should get. If you change that, then this temperature is low, you won't get a buzzer. Okay, this I'm reading from the cloud. Okay, of course in that you see that Raspberry Pi, I can show you a timestamp also. What was the last data sent to cloud and what was the data read from the cloud. Okay, with the time and date. Okay, information is not connecting. Okay, connectivity. So this is the temperature. This temperature it has read last temperature, last reading. This last reading. Okay, so something 27 now. So this 27. Its temperature is too high. Temperature is too high. Okay, like this industry, what they are doing, they have made some actuators or they have some drivers for the motors, okay, or they have some other sensors. So they set the program everywhere. So if exceed that threshold level, then that actuator has to run or the driver has to drive something, the motors, something like this in industries. This is what yesterday I said. We developed for HIL, that is aircraft battery charging discharging units. Okay, so whatever the battery charger is there, they made it automatically. So it is a 24 volts 30 amps battery charging unit is there. Okay, so once it is fully charged, it has to cut off. Charging has to be cut off. Okay, so there we put the sensors and we are watching at a server somewhere. Okay, like this is using in the industries. The same concept we can use in agriculture. You put the soils, moisture sensors, you see the readings. Okay, if it is exceeds some threshold levels, then motor should be on, water should be start flowing, or else it should be off. One of the faculty in either he did very good experiment. We placed it over this. He has made a small plant. He planted a small plant. He put on that this plant on near the pond. He put a Raspberry Pi camera. Okay, and he made small water system for us. It's a soil moisture sensor. Okay, so what he's doing? He's taking every hour the photo of the plant for 1 month, up to 1 month, and he is feeding automatic that water system. Everything will be known as Raspberry Pi. Okay, so what he's doing? When the leaf goes in small yellow tag, that leaf he is comparing with the standard tree. Like having a mango tree. What was the mango trees at 4 months leaf will be how it will be? Leaves will be how it will be. stem should be how much stem should be. Okay, the color of the leaves will be what it should go. Please comparing that. Please comparing that. Return that machine learning algorithm. Something. Then it gives you the monitor so much phosphorus, so much nitrogen has been put to change that yellow to green. He made a small model. It's very good. It's vigorously funded, worth about 3 lakhs for him. So he made that this one. It's very, very good. So we insist in this right. So has to be student has to be just such scores. They do the projects with on systems. Okay. The days has gone with rotating the arm stepper motor, DC motor with arm controller or microprocessor, microcontroller. The days has gone. So this is this era. IoT era. This is industry 4.0. Hope you know industry 1.0, 2.0, 3.0. Not industry 1, 2, 3. It is industry 4.0. Can you tell why 4.0? Not 4. Industry 1. What was it was? What the industry 1 was? Industry 1 was totally on stream. Stream based. Industry 2 is what? Electricity. With electricity, industry is done. Industry 3 is what? With computers. Interfacing. Industry 4.0 is for IoT base. We call as 4.0. It will change 4.1, 4.2, 4. Something else. Okay, it's traditional systems. Why? You see, for that we require a lot of hardware, we require a lot of software things, especially Chinese, US are starting with 6G technology. 6G technology. To process the signal of 6G technology, the processor should be processed in terms of terahertz. Terahertz. Okay, so they're designing. So you see, especially they have a Snapdragon and Qualcomm. Those companies are there. They are designing for this. Chip design should be processed at terahertz frequencies. Okay, so this will be the future. Okay, so future students will be have to start with this. What we expect in industries. They have a good score. Okay, so you people are there. You have to tell out students' mind into this. Start with the small projects, not big, small. Third year, second year, third year, fourth year. Start small projects. Good. Okay. So any doubts, sir? Any doubts? I think only short of time is there, sir. No, no. Still your time is there. Yeah. So any doubts? Because we will wind up the session. You all also plan somewhere to go near this. Drawbacks are more, sir. Raspberry Pi 1 is there. Whatever that model I defined, that import, that may work for Pi 3, may not work for Pi 2. Because it's open source. But all the that models are designed by some of us, somebody, and he put it in the GitHub. So we are taking that model and we are running. So hardware and software making code this one is very difficult task. That is the biggest issue. Or else you have to go for traditional controller. Our controller we have to write many more. We need not to call that libraries. This is one drawback is there. Second advantage is it has a mini computer. You can work anything on this. Okay, you can take this in the pocket and you can show the presentations. New else? You can make client servers architecture. You can make connect Bluetooth because it's having inbuilt Bluetooth is there. Okay, inbuilt Wi-Fi model is there. So I'm connected hardcore net via this net I'm connected. This is cable using RJ45 connector. I'm connected here. Here you can connect Wi-Fi, direct Wi-Fi, mobile Wi-Fi. How we can extract data mobile Wi-Fi. So there we are given the program. There we are given the program, SSID and password. Here you have to give here. Okay. So once show that. Turn on Wi-Fi. Remove this. So many Wi-Fi are there. We never thought that I am superior or you are superior. We never thought that you are superior, not I am inferior. Okay? We believe on one principle, a simple mathematical principle. If you had a 1 rupees point and I had a 100, if we exchange, how much will you get? 1 rupees. If you have 1 rupees and I have 1 rupees. Now, let me put one to you. If you have one good data and I have another good data, if we exchange, we'll get two good data. So we believe on this principle. Okay? So we are always open to any feedbacks. Okay? Any changes, nothing else. So seminar has to be how the 2-day session. If it is worst, good, bad, very good, all things will be accepted. Okay? Whatever changes you want to do there, let me know. So the next somewhere when we have some seminars, workshops, we'll make a changes there. I requested to sir, give me that 2-day full day. But sir said that as per the norms, it's only having the 5 hour sessions. So in within 5 hours, what I can do, I did. Best for the best things. Okay, I insisted, sir, I requested 2 days, full days. Yeah, that says syllabus is for the norms. Okay, so in the 5 hours, we did this much. Okay, so further any thing is that, let me know. So if I were somewhere wrong, if I wrote something wrong in that, let me know also. I accept that. It is wrong. If you have learned much more, then also I suppose to know. Okay? And apart from this, I should tell to students, the same thing I'm going to tell to students also. Don't take it seriously. Just I'm telling you. Usually I tell to students, whenever I go for the students, the end of the session they give some feedback. Students have to give feedback also. The students will give some feedback. I used to tell students, you give my any remarks. It doesn't matter for me. Okay? It doesn't matter for me. You attend or not attend, it doesn't matter for me. My salary will get rated as per the norms. Okay, the only loss for students is give not pay attention to the sessions. Okay, you give any remarks, I don't matter sense. I should even I will tell that I will not give you marks. I am not here to make you the analysis. Okay, not you are going to held up my salary. Okay, so something like this. So open platform, whenever you will have such events, it should be open platform. Okay, fine. So anybody is interested, let us know. Okay, fine. So we wind up. So,
Thank you, sir, for sharing your knowledge. We appreciate all the valuable insight you have provided. Now, I would like to request Professor Sunil Hebale, sir, to present the memento to our resource person, Mr. Chidambar Kulkarni, sir.